Okay, so the last topic for this part 1 of chapter 6 is independent random variables. So if you remember what we have talked about so far, we talked about joint distribution, right? Joint CDF, joint PDF, and then of course how to get marginal from the joint, how to define conditional, and then we also did exercises for the cases of two discrete random variables and then two continuous random variables. Okay, so now we're ready to define independent random variables. Okay, so while independent random variables, like with the plural form there, you know that we're working with multiple variables again, okay? And then we are trying to define what independent means for them and then how to show things are independent or how to use the fact that they're independent to solve some exercises or questions, okay? So the definition goes this way, okay? The random variable x and y are independent, okay? If any real sets A, B on real line, okay, the joint probability of x is within A and then y is within B is the product, okay, of the marginal probability of x within A multiplies with the marginal of y is within B, okay? So this is the definition itself, okay? But then of course in practice, there are a few ways that you can do to check if x and y are independent, okay? And this are if and only if, okay, meaning that if x and y are independent, those holds, and then if any of those holds, x and y are independent, okay? So the first one is working on the CDF. If you want, then if you're able to show the joint CDF is the product, okay, of the joint of the marginal of the two, okay, then you know they're independent, okay, and vice versa, right? It's two-way. And if both are discrete, okay, then you can work with the joint PMF, okay? If you can show that the joint PMF is the product of the marginal PMF of each, okay, then you know they're independent, and the other way around works as well, okay, because of if and only if, okay? The last one is if both are continuous, okay, you can work out the joint PDF, right? If the joint PDF can be written as the product of the marginal PDF, okay, then you know that they're independent, and also if they are independent, then you have this as a fact, okay? So notice that we haven't talked about or didn't illustrate an example or like a case of what if you have one continuous, one one discrete, okay? And you can always go back to the CDF for that kind of cases. All right, so those are definitions as well as results that you can use. So now let's work on an exercise, okay? The question goes, a man and a woman decide to meet at a certain location. If each of them independently, okay, so notice keywords, okay, it's independent, okay, arrives at a time uniformly distributed between noon and 1 p.m., find the probability that the first to arrive has to wait longer than 10 minutes. Okay, so feel free to pause, okay, to work it out, to give it a try, okay? So here, we know that they're independent, okay? The second thing is that each of them, right, is uniformly between the 60 minutes, okay? So let's maybe start with defining, okay, the question. I use mathematical terms, okay? Let x and y be the time that they arrive, okay? Uniform between 0 and 60 minutes, okay? And I'm including a graph here so that it's another thing useful for you to try as well, is that, well, both of them are for 60 minutes, right? From 0 to 60, okay? So we're essentially creating a square here, okay? One is represent x, the other one represent the y, okay? And then it's specifically, okay, this graph is useful because we can actually figure out the area, okay, out of this square to represent the event that we're trying to figure out the probability for. Okay, so the question, probably like the event that we're trying to figure out is find the probability that the first to arrive has to wait longer than 10 minutes. Okay, so for x, okay, if x needs to wait longer than 10 minutes, okay, so what does that mean? And then for y to wait for longer than 10 minutes, what does that mean? Okay, so for us, we are showing you a graph, right, like here, and then we're figuring out for this 2 tens over here. Okay, so what this is saying is that if, right, and mathematically, right, we know that we're trying to figure out the probability, okay, of x and y, the difference of it, the absolute value of it is greater than 10, Okay, so with this, yeah, let's come back to this graph one more time. Okay, so with this in mind, okay, we can try to graph it out. Okay, you can either start to do it directly or like maybe simplify this mathematical notation a little bit more. Okay, so the absolute value, right? The difference of the absolute value greater than 10, that corresponds to this event that we're interested in. Okay, and then of course you can break it into two cases, right? Because it's well, it's absolute value greater than 10, so it's either y is greater than x plus 10 or y is smaller than x minus 10. Okay, and they're disjoint, so we're adding up the probability. Okay, and the next thing is that well, I guess this will be a good time to start to sketch this out on this graph, right? Like we have this 10, the 210 over here, right? This upper area, it's a triangle, right? This one represents the case, I think, of y is greater than x plus 10, right? And then down here, that's the other one of y is smaller than x minus 10. Okay, so whichever you do, but one thing we wanted to highlight is because it's uniform, right? Like x and y, they're uniform arriving. So they are, well, these two are symmetric, right? So you can actually just work out one of them and then multiply by 2 to get the total. Okay, so let's just say we pick, okay, 2 times the probability of y is greater than x plus 10. So it's this upper area. So let me erase this. Okay, so the one that we decided to work on, or I decided to work on, is this one. Okay, all right. So regardless, once you get to this point, it is still very important to know that we need to do a double integral to get the probability of this event, right? Because you have x and y, and then this is a particular set region that you're integrating with respect to. Okay, so just to get us started, we have 2, so that's a constant. Multiply, 2 multiplies the double integral. Okay, the double integral, of course, is within the range of whatever we need to do of the joint PDF, right? And then dx dy. Okay, in this case, we're having y is greater than x plus 10, which is this area that we talked about. Okay, so we do that. Okay, and the next step, okay, don't forget, well, we don't know the joint, I guess, but in some way we do, because we know that, okay, so this is the key here. We know that they're independent. Okay, and then from the if and only conditions that we're talking about earlier, if 2 random variables are independent, in this case 2 continuous random variables are independent, then their joint PDF, right, is the product of the 2 marginals. Okay, that's why we're able to break it into this 2. Okay, and lastly, so for each of them, okay, I think it's 1/60, right, because it's uniformly between 60 minutes if we're using minutes as the unit. Okay, so it's 1/60 for one, 1/60 for the other, so that's all good. And then we need to work out the bounds, okay, now for this double integral. So the bounds, if I focus on this one, okay, you can say, okay, so this is the case that we're doing dx dy. Okay, so for y, the range is from 0 to 60. Okay, so that's how you get those two. Okay, and then for x, okay, just be careful here. If you're fixing, yeah, so for given a y, if you're looking at x, right, I think the upper bound is this line, right, and the lower bound is this line. Okay, so that's why the upper bound, we know, is y minus 10. That's what that line is. Okay, and then the lower bound is 0 in terms of x. Okay, so eventually, if you do this, you're gonna get 25/36. Okay, so hopefully that makes sense. And this will be the case if you want to give it a try. Highly recommend. Okay, try to do dy dx. Okay, this will be the case that I think is probably similarly difficulty level of doing dx or dy, dx dy or dy dx. Okay, so unlike before, you have to break it into 2 different cases. Because of the shape of the area they're integrating with, but now this case is just a triangle, right? So if you work out the other one, it should be overall straightforward as well. I think the upper bound, right, will be this one for y, okay, and then the lower bound. Oh, sorry, let me take that back. Okay, actually, this should be the upper bound. Sorry, if you're doing dy dx and then thinking about the dy part, and then this should be the lower bound, okay, because you're looking at in terms of y. Okay, so you see, it's easy to make mistakes, right? So just slow down, don't rush, and then do it step by step. I think you will eventually get it. Okay, so again, for us, okay, if you have discrete or continuous random variables, if and only if they're joint PDF or PMF, okay, can be expressed as the product. Okay, so here we're writing it more generically. Okay, if you have X and Y independent, and then it could be discrete, it could be continuous, right? So the joint, okay, can be written as the product of the two. So sometimes you might have continuous and discrete at the same time. So you can also think about that. Okay. Lastly, more than two random variables if you're working with, so they're independent if this joint probability, right, of a like x1 within a1, x2 within a2, up to xn within an is the product of all of the marginal. So that's very similar to what we have defined for only two random variables, okay? And then all of the if and only statements, okay, stayed the same, but we're now expanding it into more than two, right? So the joint CDF is the product of all of the marginal. The joint PMF is the product of all of the marginal, and the joint PDF is for all of the product of the marginal. All right. So yeah, so just like I said, slow down, don't rush. And then this also, like the particular exercise that we have seen actually also involves, right? Involves doing double integral, right? So you need to be super careful about the bounds and just do it slowly. And I think eventually you will get it for sure.